Hi everyone, Mr. Mark here. In today's video, I'm going to be showing you how to do the least squares regression line, or essentially it's just a line of best fit. Now, in previous years, you've probably looked at an equation of a line in the form of y equals mx plus c, where m was the gradient, and if it was a positive gradient, it was sloping upwards from left to right. For us, that means that we have a positive correlation between those two numerical variables. If m was negative, obviously it would be sloping downwards from left to right, and for us, that would suggest a negative correlation between those two numerical variables. And in that form, y equals mx plus c, c was the value of the y-intercept, so where the line crossed the y-axis. Now, when we're using our graphics calculator, we're going to be asking it to give us the values of m and c, so the slope and the y-intercept. But though instead of m and c, they'll be giving us values a and b. So y equals ax plus b, where a will be our gradient and b will be our y-intercept. So with that, let's look at our example here. The annual income and average weekly grocery bill for a selection of families is shown below. In our top row here, so our X or explanatory variable, we have the income of those families in thousands. So this 55 represents an income of 55,000. And in the second row here, or the Y values, the response variable, we have the grocery bill or the weekly grocery bill in dollars. So for a family that has an income of 55,000, the average weekly grocery bill is $120. So it says to, first of all, construct a scatter plot to illustrate this data. Again, we're going to be doing that in the graphics calculator. Again, to save a little bit of time, in the stats function, I've put in the X variables, the explanatory variables, into list 1, and the Y variables or the response variables into list 2. So that one is now done. It then asks us to use technology to find the least squares regression line. When it asks that, it's actually asking for the equation of the line. So what is the equation in the form y equals ax plus b? And to do that, very similar to what we were doing in my previous video to find r and r squared, you go to graph, or you can go through calculate, but go into graph, that's why I like doing it. Just make sure that your graph is set to a scatter plot with list 1 representing your x variables and list 2 representing your y variables, as I just showed you. And then press F1 to draw that scatter plot. Then once the scatter plot comes up, so there are the families there, each represented on that scatter plot by a different point. Go and press F1 for calculate. X and ax plus b, see that looks familiar. Okay, over here. And when in here, you can see obviously the values of r and r squared, which we've already looked at previously, but it also gives us values for a and b. Okay, a in this case obviously being our gradient, and b being our y-intercept. Okay, so if I'm to write that or rewrite that equation for b, it would be y equals, it was about approximately 4.18. I rounded that to 2 decimal places, 4.18x minus 56.69. Again, just rounding the value of b there to 2 decimal places. So that's the equation of that least squares regression line, or that line of best fit. So if I go ahead and draw that, okay, the equation of that line is represented with this equation here, obviously. So moving on to C, it says state and interpret the gradient of the least squares regression line. So the gradient we've already said is that value of A, which is 4.18. And again, I've rounded that, approximately 4.18. It says to interpret the gradient of the least squares regression line. So what does it mean in terms of this problem? Now remember, gradient is usually given in the form of rise over run. Okay. And if there is no fraction, we assume that that is over 1. So here it is 4.18 over 1. with 4.18 being our rise, which is the change in that y variable, okay? And 1 being our run, which is the change in that, that x variable, okay, across the horizontal axis. So what does it mean in terms of our problem in terms of, you know, the y and the x? Well, basically it's saying that for every increase in income by 1,000, every $1,000, so I should start again. Every increase in income by $1,000, there is an increase in the average grocery bill by $4.18 or $4.18. So interpreting it in terms of the problem, for each or for every $1,000 increase in average income, the average grocery bill, or the average grocery bill, increases by $4.18. Okay, so that's what it means in terms of the problem. Moving on to B, it says estimate the weekly grocery bill for a family with the annual income of $95,000. Now, there's a few ways of doing this. The first way, now that we know the equation, is to substitute, in this case, that value back into the equation. So for D, we're looking at an income of $95,000, which is our X variable, but you know, the table of values here, it's writing it as thousands, so we'd only have the X value of 95. Remember, this 55 represents 55,000, this 60 represents 60,000, etc. So this 95 is going to represent 95,000. So we can then substitute that back in to the equation. So sub in X equals 95 into our equation, which was Y equals 4.18x, or 4.18 times now 95 minus 56.69. Yeah, so we can just throw that into a calculator and ask it what the value will be. So 4.18 times by 95 minus 56.69, which equals approximately, let's just go to the dollar there because that's what they're doing with the variables that they're giving us here. It's approximately $340. Now, the other way of doing it is using a graphics calculator. And I suggest, you know, yes, great to do that, but understanding how to use your graphics calculator is a big tool as well. So once we're in here and we've got those values, what it's best to do is to copy this, or these values of A and B, basically that equation, into our graphing function, because it has more functions than the graph within the stats function, believe it or not, okay? Don't ask me why. So we're going to copy the equation here by pressing F5 once you're in this screen, okay? And I'm going to copy it there. It's already there, but here, execute again. It's now copied into the graph function. So exit the stats function, okay, and head into the graph function there, which is 5. And there is the equation. Now, I obviously rounded off the value to 4.18. Here you can see they haven't rounded it off at all. So you can't even see X, but it's probably like to 12 or 14 decimal places. So there will be a slight difference in the answer that I got because I rounded those values off, and the answer I'll get using this graphing technique, but it will be very similar. So once I get that, select that by pressing F1 and ask it to draw it for us. And then what I can do is just put in the value of 95. But before I do that, obviously looking at Shift F5 to G solve, go across here by pressing F6. So I've got YCal and XCal. So what I'm asking for is I'm asking for a Y value based on an X value of 95. So I want to YCal if X is equal to 95, okay? Saying it's not possible because it's outside of that view window. So now what I need to do is I need to change the view window. So let's exit. If this ever happens to you, you need to change that view window. So go back into Drawer, Shift, View window here, and we want to obviously have that maximum X scale, you know, greater than 95. I like to set the minimum to a negative value so that I can see that X-axis in my view window. My maximum here is going to be, let's go 100 just so that we encompass that 95. And for my y axis, again, let's set it as -5 so we can see that. And let's set the maximum to, obviously it needs to be more than 340, I know that. But again, you can make it a little bit bigger if you want. Let's set it to 450, for example. It doesn't have to be that. And then go ahead and hit execute and draw. And now if I do the same process, shift G solve, F6, ycal, F1, put in the value 95. So when X is equal to 95, Y should be equal to approximately 340. So when X is equal to 95, Y is equal to 340 and 23 cents. Again, I think when I did it on my other calculator, it was $340.41. But remember, the difference there is because I rounded the equation here, okay? So this is actually more of an accurate answer. Both are acceptable, okay? Obviously, if you're showing that working out in a test or exam situation. So yes, Y is equal to approximately $340. Or if the average income is $95,000, then the average weekly grocery bill you would expect to be $340, potentially. We'll get to that in a minute when we get to F. Let's look at, before we talk about that though, and how reliable that answer is, let's look at E. So it says, estimate the annual income for a family whose weekly grocery bill is 100. So now what we're doing is we're basically giving for E, a Y value of, in this case, 100. So we're going to sub in Y equals 100. Okay, when we do that, sorry, you can see that. Let's get rid of that. So sub in Y equals 100. So then 100 equals 4.18x, take 56.69. And we just solve again here algebraically, right? So the first step would be to add 56.69 to both sides to cancel that out, which gives us $156.69 is equal to 4.18x. Then we obviously divide by 4.18 on both sides to cancel out that 4.18, or the coefficient of x. So 156.69 divided by 4.18 is 30. Let's go 37.5. So x equals approximately 37.5, or in the context of the problem, that is $37,500. That's what we would expect the income of that family to be if their weekly grocery bill was $100, obviously based on the model that we've created here using this least square regression line method. So the last part there says, comment on whether the estimates in D and E are likely to be reliable. Now, D, if I go, and this is a little bit tricky, but if I go back to the stats function and look at the scatter plot, okay, this is my lower pole and this is my upper pole, and it's important that when we're trying to predict value based on this least squares regression line or this line of best fit, that it fits in between those two poles, the interpolation that we've spoken about before. So 100 does fall in the range. So I won't write about this, but the answer to E is reliable because of interpolation. Okay, it falls within those ranges. Look, there's a value that's less than 100 here, in the Y value, so 60, and there's a value that's greater, 120 or even 250. So my answer to E is reliable because it's interpolation. We've taken that we're interpolating that prediction from between the poles. Whereas D is not as reliable because the value that we got given here was 95,000. And 95,000, if you look at it, is larger than any value that it's given in the real data. Okay, so if we then look at that scatter plot, this last point here refers to someone who earns $64,000 and spends $250 per week on their grocery bill. So a an income of 95,000 would be well off the chart here. Okay, I'd have to extend my view, and I won't do that. But you will see, you can obviously see then that exceeds that upper pole. Okay, and that's what we're talking about in terms of extrapolating that prediction from outside the poles, which means it's not necessarily reliable. The other thing to add with part D is we've obviously seen that there is a positive correlation between these two variables, and the value of R is 0.89. It suggests that there is a strong correlation between these two. And we can assume that there is a causal relationship between these two, which then obviously adds to the reliability of my answer to E, given that in fact it is interpolating, the prediction is interpolating in between those two poles. Whereas with D, although there was still that strong positive correlation, we're extrapolating that prediction from outside the pole, so it's less predictable. All right, so that's it, guys. Hopefully that helps a little bit about the least squares regression line method and how to do that. It's basically a line of best fit through the graphics calculator.